is numbered 723. It's titled Identifying Quadrilaterals on a Coordinate Plane. And we're going to answer the question, what kind of quadrilateral is it? So question 105 says, the Shape Factory. You just got a job in the Quadrilaterals division of your uncle's Shape Factory. Your uncle needs your team to help analyze the most recent orders listed below to identify the quadrilaterals and help the shape makers know what to produce. Your task for both of the quadrilateral orders listed below. 1, create the diagram of the quadrilateral. 2, give the most specific special name. And 3, justify your name and explain how you know its name. So order number 1, a quadrilateral formed by the intersection of these lines. So there are 4 lines. We're going to graph them on your coordinate plane. I had 4 colors, so I color coordinated mine, but you can just do yours all with pencil if that's what you have, okay? You have a couple different pens, like a black pen, a blue pen, a red pen, and your pencil, then you would have 4 different colors like I did. All right, so the first thing we're going to do is we're going to graph the green line. So the green line has an equation of y equals -3/2 x plus 3. This 3 is where it crosses the y-axis. So on the y-axis, you go to +3. And then the slope is -3/2. So you go down 1, 2, 3 over 2, put a point. 1, 2, 3 over 2, put a point. And then you're going to draw your line. Mine is green. Okay? The second line, I color-coded orange. It has an equation of a line of y equals +3/2 x minus 3. So this one crosses the y-axis at -3 and has a slope of 3/2. So you're going to go up 1, 2, 3 over 1, 2. 1, 2, 3, 1, 2. And then you're going to draw your second line. Okay? The next line I did in pink crosses the y-axis at +9. So on your y-axis, find +9 and put a point. And its slope is -3/2. So you're going to go down 3 over 2, down 3 over 2, and draw your line. Okay? And the fourth line, I did mine in purple, had a y-intercept of +3, so the same place that the green line was at, and a slope of 3 over 2. So you're going to go up 3 over 2, up 3 over 2, and draw your line. So you're going to end up having all 4 lines drawn. Those 4 lines end up creating this quadrilateral in the middle. Who remembers from the other day what shape that quadrilateral most looks like? Yes, sir. Well, it's definitely a parallelogram, but we can get slightly more specific than that. Yes, it is. It is a rhombus. So the most special name for this quadrilateral is a rhombus. If you said parallelogram, you wouldn't be completely wrong, but it wouldn't be the most special name. Yeah, so it's technically still a parallelogram, but even more special, it's a rhombus. Okay? How do you know? Compare the slopes and side lengths to justify your claim above. So the 2 lines going up from left to right have a positive slope of 3 over 2, 3 over 2, and this one has a slope of 3 over 2, 3 over 2. So when your slopes are the same, that means they're parallel. The 2 lines going down from left to right have a slope of -3 over 2, -3 over 2. And then this one is also -3 over 2, -3 over 2. So the 2 going up have the same, the 2 going down have the same. And all the sides are the same length, meaning they're all congruent. That makes them a rhombus. Okay? I'm going to move this up. You'll see it in just a second. If you're still writing, we're going to head to the top of the next page, and we're going to graph some points this time instead of just graphing lines. There we go. Still writing that last little bit of answer there. All right, order number 2 says a quadrilateral, this time with the vertices at these points. So we're going to graph these 4 points and then make our own quadrilateral. Okay, so A is at 0, 2. So on your graph, 0, 2 means here's a 0, so you don't go any right or left, and then you go up 2, put a point, and label it A as an alpha. Point B is at 1, 0. That means you go 1 to the right, and then you don't go any up or down, put a point, label it B as in boy. Point C is at 7, 3. That means you're going to go 7 to the right, up 3, put a point, label it C as in cat. Point D is at 4, 4. So you're going to go 4 to the right, up 4, put a point, and label it D as in dog. Okay? Then you're going to use your ruler or your student ID, whatever it is that you have that's flat, and you're going to connect all 4 points, A to B, B to C, C to D, and then D back to A. Okay? Has 4 sides, so that definitely makes it a quadrilateral, but more than that, it has an even more special, specific name. What is it? It is a trapezoid. Good. Okay, so it's a trapezoid, but it also has one other special thing. It has a right angle right here at A, B, C. Okay, so it's most specifically called a right trapezoid, which you don't see very often. And question F says, how do you know? Compare the slopes and side lengths to justify your claim. The slopes are as followed. Line segment AD has a slope of up 2 over 4. So I went up 2 over 4. Well, then I realized, okay, you can reduce that, right? 2/4 reduces to 1/2. Okay. How about B to C? From B to C, how many do you go up? Count it on your paper. From B,
3.
you go up 3, and then over how many?
7.
I got 6. So up 3 over 6. 2/4 and 3/6 do not look the same, but when you reduce them, they both reduce to 1/2. Okay? The other thing is that this little segment right here, AB, we're going down 2 over 1. So I got -2 over 1, which is the reciprocal, and it's the opposite sign, meaning it's perpendicular or forms a right angle with AD to AB, well, technically AB to BC as well. Okay? So this little symbol means parallel, and this little symbol means perpendicular. Okay? Finish copying that down.